It's like a red-hot frying pan, except the pan would melt your hand like in a terrifying dream. Listen, just imagine stepping onto a surface where temperatures hit a blistering 1500 degrees Celsius. You're getting absolutely pummeled with 500 times the radiation of our own sun on a planet that completes an entire year in just 7.7 days. That is the reality of Giza 367b. It's essentially a cosmic jawbreaker, just a molten iron ball. It's honestly as if a planet-sized blowtorch blasted off the entire crust and left nothing but a glowing, broiling core. Welcome to the Explainer. Today, we're going to be skipping the usual peaceful celestial vacation spots. Instead, we're taking a structured and frankly incredibly disturbing tour of the cosmos' most hostile, deadly, and downright terrifying locations. I'm going to guide you through a galactic itinerary of planets that just defy logic, planets that shouldn't even exist, and worlds that would vaporize you, squash you flat, or literally turn you into Swiss cheese in a matter of milliseconds. So here's our roadmap for today. We're looking at 5 terrifying planetary biomes: scorched Earths and cores, tsunami worlds and steam, gas giants of terror, bizarre and deadly weather, and finally, doomed worlds of magma. All right, let's jump right into our first stop, scorched Earths and cores. Now, we hear the term Earth-like tossed around in astrophysics all the time, right? It basically just means a planet has a silicate rock crust and an iron core. But, spoiler alert, just because a planet shares Earth's basic anatomy absolutely does not mean it's inviting, breathable, or anywhere close to safe. Take TOI 849b, for example. It whips around its star at a roasting 1500 degrees Celsius. But what's really wild is its mass. It is a massive, 40 times the mass of Earth, all crammed into a tiny space roughly 3.5 times the width of our planet. So why does that matter? Well, TOI 849b breaks pretty much all of our common scientific wisdom. According to the rules of planetary formation, when a planet hits about 10 times the mass of Earth, its intense gravity should trigger runaway gas accretion. It should pull in massive amounts of hydrogen and helium and become a gas giant, kind of like Jupiter. But since TOI 849b is 40 times Earth's mass and is still just a rocky core, scientists believe it actually was a gas giant until some unimaginable cataclysm ripped its entire gas exterior away. And then we have KOI 55b, which pushes this extreme even further. Just to put this in perspective, our sun's surface is around 5,500 degrees Celsius. KOI 55b is 7,000 degrees Celsius. It's an Earth-like planet that is literally hotter than the surface of our sun. How is that even possible? Well, it's the surviving glowing core of a massive gas giant that fell into a death spiral, smashed deep into the outer layers of its own red giant star, and miraculously emerged on the other side, scoured of everything but its superheated glowing core. Moving right along to Section 2, Tsunami Worlds and Steam. Think about our own blue planet for a second. Earth is actually a mere 1% water by mass, but a planet like TOI 145b, it could be up to 30% water. That means an absolute horizon of endless oceans, completely devoid of any land whatsoever, running hundreds of kilometers deep. But endless deep oceans aren't the only water hazard out there. Consider a world kind of like Miller's planet from the movie Interstellar, which, by the way, is firmly based in real, possible science. On a planet like this, the seas are actually incredibly shallow because all the water is bound up in constant, rolling 4,000-foot tidal waves that just erase any standing features. And because it orbits incredibly close to a massive black hole, the warped space causes severe time dilation. For every single hour you spend surviving those waves on the surface, 7 whole years pass back on Earth. Next up, Section 3, Gas Giants of Terror. We are leaving solid ground entirely. I want you to hold this staggering number in your head, 9,000 kilometers per hour. That's roughly 7 times the speed of sound. Those are the supersonic winds you would experience the literal moment you began your descent into the atmosphere of the Jupiter-sized gas giant, HD 189733b. From a distance, this planet is a deceptively beautiful, calming blue. But don't let that fool you. That color isn't life-giving water, it's blisteringly hot clouds of silicate particles high up in the atmosphere. Caught in those 9,000 km/h winds, you honestly wouldn't last a single second before being literally shredded by sideways blowing supersonic glass rain. If glass rain doesn't freak you out, how about WASP 12b? This carbon-rich gas giant has so much carbon in its atmosphere, it could theoretically be made of diamond. But this bling planet is actually pitch black. It absorbs 94% of all light that hits it. Yet, the environment is so impossibly hot that this pitch black darkness actually glows yellow. And in a final twisted irony, the planet is slowly being stretched and basically eaten alive by its own host star. All right, Section 4, Bizarre and Deadly Weather. Let's break down the sheer madness of exoplanetary meteorology. Over on WASP 76b, daytime temperatures hit 2,200 degrees Celsius. That's hot enough to vaporize surface iron into steam. When it blows over to the cooler night side, it condenses into literal iron rain. Then you have HAT P7b, a dark, wind-whipped world with clouds of corundum, which is the mineral that makes rubies and sapphires, meaning it rains actual gemstones. And finally, GL436b, where temperatures hit 300 degrees Celsius, but the intense gravity crushes water molecules into solid, highly pressurized hot ice that would act like a bomb if it ever decompressed. The crazy thing is, we don't even have to leave our own solar system to find disturbing weather. Saturn's moon Titan features a freezing -179-degree environment where water acts like solid rock and highly flammable liquid methane runs in rivers, bordered by deserts of explosive hydrocarbon grains. And deep inside Jupiter, the pressure is so immense it jams hydrogen molecules together until they lose their electrons. This creates a bizarre core of liquid metallic hydrogen that actually conducts electricity and generates the planet's massive magnetic field. And finally, Section 5, Doomed Worlds of Magma. Take a look at the terrifying weather cycle on K2-141b, a planet that's tidally locked to its star. Step 1. The searing 2,700-degree dayside heat melts the surface into a literal ocean of liquid magma. Step 2. The extreme heat actually vaporizes the rock into the atmosphere. Step 3. Supersonic winds catch this rock steam and blow it to the freezing cold night side. And Step 4. The vapor condenses and falls back down onto the surface as rock hail, which then slowly grinds its way back to the dayside to repeat this entire nightmare cycle. And then there's our unlucky final planet, BD plus 054868AB. Orbiting 20 times closer to its star than Mercury is to our sun, it completes an entire orbit in just 30.5 hours. Down on the surface, it's a continuous global firestorm. The intense radiation is effectively blowtorching the entire planet, causing it to lose the equivalent of a mountain's worth of material every single day. Now, this constant blowtorching leads to something pretty remarkable. It strips away the surface to create an incredibly beautiful yet horrifying 9 million kilometer long comet tail of superheated molten rock trailing behind the planet. This tail stretches a full halfway around its orbit. It's an amazing sight for sure, but it means BD plus 054868b is dissolving right before our eyes. It's a pretty intense reminder that on a cosmic scale, even planets are temporary. So, as we wrap up our truly disturbing cosmic tour today, I want to leave you with this thought. If these are just the planets we know about, how utterly terrifying is the true scale of the universe? Ponder that tonight as you gaze up at those deceptively peaceful stars. Thanks so much for joining me on The Explainer.